Now, there are two sheets that you got today. One of them says postulates at the top and is a whole list of postulates, front and back. It's only one page. And the other is the note sheet. So the reference sheet, it should say reference also at the top, is for y'all to use. Because y'all will be able to use that on the test with your review sheet. Because I'm not expecting you to learn all those postulates. And on the postulate sheet, we're not going to cover all of those. But a majority of them are what we're going to use. We're not using all of those yet. But that is a sheet straight from your textbook. It is in the back of the textbook. As you can see at the bottom, A101 is the page number. So it's at the very, very back of the textbook. And those are there for you to utilize if you need. Pretty much, yes. Now, we're going to look at today's lesson if there are no questions on the homework. Now, this has already been filled in for you. I'm not making you fill these in, but we're going to look at a few postulates first. So the first postulate that we have is 2.1, two-point postulate, the two-point postulate. Now, the two-point postulate says through any 2 points there exists exactly one line. Well, yes, because through any 2 points on a plane, we can draw exactly one line through those 2 points. That's the two-point postulate. The line point postulate states that a line contains at least 2 points. So if I have a line, I know that there's at least 2 points on that line. So they kind of go back and forth with each other. Because if I have 2 points, then I can draw a line through those 2 points. If I'm given a line, then there's at least 2 points on that line. Through points A and B, there is exactly one line L. Line L contains at least 2 points. That is utilizing those postulates. Now, 2.3, line intersect postulate, states if 2 lines intersect, then their intersection is exactly 1 point. Because when 2 lines do cross, they are going to cross at exactly 1 point. So the intersection of line M and line N is point C. And these are the next 3. 3-point postulate. Through any 3 non-collinear points, there exists exactly one plane. So if I have 3 points, I can make a plane from those 3 points. Now the plane point postulate, just kind of like the line point postulate, states if I have a plane, then there exists at least 3 points that are contained within the plane. Again, those kind of go back and forth. If I have 3 points, then I can 3 points that are not on the same line, I can make a plane. If I have a plane, I have at least 3 points. The plane line postulate. 2 points lie in a plane, then the line containing them lies in the plane. If I have a plane with at least 2 points in it, or if I have 2 points that lie in the plane, then I can make a line that goes through those points and is contained in the plane. Point D and E lie in the plane R, so line DE lies in the plane R. And lastly, the plane intersection postulate. If 2 planes intersect, then their intersection is a line. Questions on this here? Okay. So this here is going to be a little bit easier than you think it might be. So the instructions say what? Okay. So we're just stating the postulate, yes? So what is this picture illustrating? If what? Intersect, then what? Well, it's kind of hard to see, but there is a red dot right there at the... So we have if two lines cross, then what? They intersect at a, what postulate is that? Line intersection postulate states what? If two lines intersect, then their intersection is exactly 1 point. So the postulate that this is illustrating is the line intersection postulate. Let's try to, oh, it's right there. Line intersection postulate. If two lines intersect, then their intersection is exactly 1 point. Yeah, that's all we're doing, because that's all it asks for. Questions on this here? Are you ready for the next one? State the postulate illustrated by the diagram. So what do we have? If what? Then? It'll be the plane intersection postulate. If two planes intersect, then their intersection is a line, is what the postulate actually states. But it is the plane intersection postulate. Questions on this here? Now, this here is really just getting us familiar with these postulates, because once we have the postulate and we know that it is true and we've shown that it's true, we don't have to show it again. So really, once we get these postulates and know that they're true, we can utilize them from then on. Which means that if I know that two lines intersect and I see that they intersect, well, I know that there's going to be a point of intersection that we can utilize. That means I'm not having to go back to the definitions of lines and intersections and proving that again, because we have a postulate that states it. Now, when we look at this one here, state the postulate illustrated by the diagram. If what? Then it contains at least 2 points, yes? And this is what? The line point postulate. Because if there is a line, then there exists at least 2 points on the line. Questions on this here? Plane point or point plane? So 3-point postulate states through any 3 points, 3 non-collinear points, there exists exactly 1 plane. Plane point postulate says a plane contains at least 3 points. So what do we have first? If there are 3 points, then a plane. So this here is the 3-point postulate. That's also why I give these sheets to you, so that y'all can look back on them. Because some of them are very close together. So like the 3-point postulate and the plane point postulate are very close. They're very close together in what they are. So a plane point postulate says what? A plane contains at least 3 non-collinear points. So what do we start off with a plane point? We start off with a A plane. A plane contains at least 3 non-collinear points. So we're saying we have a plane, then if there's a plane, then there's at least 3 non-collinear points. 3-point postulate says through any 3 non-collinear points, so we're starting off with what? 3 points, then there's exactly 1 plane. So one of them, the 3-point, is starting off with points and saying we can create a plane. The plane point postulate says I have a plane, that means there is at least 3 points. So if it said those are flipped, then yes, then it would be the plane point postulate. And again, that's why I give you this here, so you can refer back to it. Because it's very easy to get these flipped. So referring back to this is not bad. Because I actually there's a reason I'm holding it, to look back at it. And I definitely snuck a peek at Haley's while she was flipping back and forth. So it's good to look back on this. Now, will you use these after this class? No. But it's good, especially the logic and reasoning, thinking through this is more useful than the knowledge itself. Use the diagram to write the examples of the plane point postulate and the plane line postulate. So plane point postulate says what? A non-collinear points. So our plane point postulate, so we can say what? Plane P contains what? What contains points what? I agree with the A. Why not N? Is N a point? N is the line. And I'll try to do this and make sure that this lines up, especially on the test. But if you notice the 2 that are naming the lines N and M, what's the difference between them and the points and how they did it? How they set this up? It's really in how they look. Because N is what? Lowercase. Yeah, it's a line. They try to make that distinction because if you look at the points, A, B, and C are all capitalized, aren't they? Yep. So they try to make a distinction between them. And again, on a test, if you have a question about that or not sure if that's naming the line or naming the point, ask. I will clarify. I will clarify stuff like that. Questions on the first part of this with the plane point postulate? Points A and B also lie on plane P. Okay, so they were just clarifying that. Plane line postulate states what? So we can use plane P or plane Q. Which one do we want to use? Plane Q we're going to have to use plane P for this here. Q doesn't quite work for one main reason. Because Q does have a line. It has line M, yes? Now, just looking purely at the postulate, plane line postulate, if 2 points lie in a plane, then the line containing them lies in the plane. How many points are contained in plane Q? A. A is contained in plane Q. Plane P going the other direction has a B and C. B and C, the other 2 points, are not contained in plane Q. Yes? So if we look purely at the postulate, if 2 points lie in a plane, well, does plane Q have 2 points? It only has 1. So we can't really use this with the postulate. But plane P contains points A and B. So the line AB is contained in the plane. I ran out of room. But that's it. So with that there, we're just giving an example of how we see the postulate in the diagram for both of these here. Questions on this here? Which postulate allows you to say that the intersection of plane P and plane Q is a line? Yes. The plane intersection postulate. Plane intersection postulate. If 2 planes intersect, then their intersection is a line. Questions on this here? Write an example of each: 2 point, line point, and line intersection postulate. So 2 point says what? Through any 2 points, there exists exactly one line. So through A comma B, there exists line AB. Any questions on this here? Okay. You ready for the next one? Okay. Place that there. Line point. Well, what does the line point postulate say? A line contains at least 2 points. Line AB contains the points A and B. Are we ready for the last one? Line intersection postulate. If 2 lines intersect, then their intersection is exactly 1 point. So line M and line N intersect at the point A. Lines M and M intersect at the point A. Questions on this here? Are you ready for the next one? Sketch a diagram showing line TV intersects segment PQ at W, so that TW and WV are congruent. So sketch a diagram. So we have what to start off with? Intersects line segment PQ. We know that TV will continue on past those points and have arrows because it is a line. PQ will not because it is a segment. And we know that from the symbols above them. So we did sketch a diagram where TV is intersecting PQ at point what? So it just means I labeled the point of intersection, or right next to it, I'm going to put W. Is that it? What else did it ask for? Because we did cover this a little bit, but if we draw those little hash marks, we're saying that it is congruent. Let's see what this is here. Okay, they added a little bit here. If given information states that PW and QW are congruent, how can we illustrate that? Well, there's a little bit more, but I mean, if we wanted to show that the other two were congruent, we can draw additional hash marks on those. That wasn't listed in the note sheet. It was covered up. That's it. That's all we would need to do. Yep. Questions on this here? Sketch a diagram showing ray VX intersecting line UW at V, so that ray VX is perpendicular to UW, and U, V, and W are collinear. So
draw a line, or draw
I chose straight up and down. It doesn't matter. We could have gone left and right. Intersecting UW so that VX is perpendicular to UW. Well, if two lines are perpendicular, they intersect at what? What kind of angles? So to show that they're perpendicular, we can just put a right angle marker to show that each one of those angles is 90 degrees. So UVW is collinear, yes? So do we have that drawn here? No. So where do they intersect? V. So I drew this wrong, didn't I?
Oh, so you make the line on the bottom.
Yep. So since we noticed that it wasn't lining up with what we needed, we can change it and move point V to where the two intersect. Because now it does make U, V, and W collinear. And since they intersect at a right angle, they are perpendicular. And that's it. Questions on this here? A line is perpendicular to the plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. So if a line through that point is perpendicular, that line that contains the point is perpendicular to the line going through the plane, then it will be perpendicular to the plane. In a diagram, a line perpendicular to a plane must be marked with a right angle symbol as shown. Then we can know that they are perpendicular. Questions on this here? Which of the following statements cannot be assumed from the diagram? Points A, B, and F are collinear. So A, B, and F are right here, yes? Are they on the same line? Yes. So can we say that A, B, and F are collinear? Yes. That is true. We can say that. And we say that D, E, and B, points E, B, and D are collinear. E's not a line. It's over there. No. Line AB is what? This here means perpendicular to plane S. So does AB intersect plane S at a right angle? Yes. So can we say that AB is perpendicular to plane S? Yes. Can we say that line CD intersects plane T at a right angle? Is CD perpendicular to plane T? No, because we do not have a right angle marker at their intersection. It could be, but because we are not told that CD intersects at a right angle with plane T, we cannot assume it. And lastly, AF and BC intersect at point B. Yes. Because that is shown, and we do have it. Any other questions on these here? We good with these here? I believe these are the last two. Yes? All right. Can you assume that plane S intersects plane T at line BC? Plane S and plane T intersect at line BC? Yes. Because that's where those two planes do intersect. And lastly, explain how you know that line AB and BC are perpendicular. Because the diagram has a right angle marker at their intersection. Because the diagram has a right angle marker at their intersection. The little square tells us that they intersect at a right angle. Any questions on this here? Anything we've covered? And that is it for today. 3 through 8, 13 through 19 odd, and 21. Yes, you have about 10, a little over 10 minutes.